Welcome, everyone. Let's get started on our deep dive into managing custom security attributes in Microsoft Entra ID. We will explore how to securely extend your identity profiles, control access with precision, and implement real-world zero-trust scenarios. Let's begin by defining our core topic. What exactly are custom security attributes in Microsoft Entra ID? Custom security attributes are business-specific key-value pairs that you can define and assign directly to your Microsoft Entra objects. Think of them as highly secure, customizable tags. You can attach these attributes to Microsoft Entra users, enterprise applications, and even managed identities. The core purpose here is extremely powerful. We use them to store specialized information, categorize objects for detailed auditing, and enforce highly granular, fine-tuned access control over specific Azure resources using Azure Attribute-Based Access Control, or ABC. For instance, you could extend a user's profile to include an hourly salary attribute, categorize hundreds of apps for a compliance audit, or specifically grant users access to Azure storage blobs that belong to a highly restricted project. They form a foundational pillar for identity-driven security. Looking at this diagram, you can see how Microsoft Entra ID sits at the top, acting as the foundation. From there, custom security attributes flow down and can be attached to three primary types of identity objects: users, enterprise applications, and managed identities. Notice the dotted lines extending from each object. These represent the real-world outcomes. For users, these attributes extend their profiles with rich, business-specific data. For enterprise applications, they allow for deep app categorization and filtering. And for managed identities, they drive resource authorization. This visualizes that custom security attributes are not just static data points. They are active, functional components that drive your security posture and identity management architecture across your entire cloud environment. A common question is, why not just use standard directory extensions? The answer comes down to security and data sensitivity. While both extensions and custom security attributes allow you to add custom data to objects, they are designed for fundamentally different scenarios. Anyone who has permissions to read a user or application object can read its standard extension data. This makes standard extensions completely unsuitable for sensitive information. Custom security attributes, on the other hand, restrict read and write access through a completely separate, highly secure set of permissions and role-based access control, or RBAC. Therefore, if you need to store sensitive data, like clearance levels or salary bands, or if you need to use this data for actual authorization scenarios, custom security attributes are your required path. They give you the flexibility of extensions, but with enterprise-grade security hardening. This comparison graph clearly illustrates the divide between standard extensions and custom security attributes. On the left side, we have standard extensions. As the flow shows, general data placed here is readable by anyone who can view the object, leading directly to the conclusion that it is not for sensitive data. Now, contrast that with the right side. Custom security attributes start with sensitive data, which is then shielded by strict role-based access control, or RBAC. This robust protection layer is what ultimately enables the final node, using these attributes for strict authorization scenarios and attribute-based access control. This diagram is a great mental model to use when deciding which feature to implement for your specific identity data needs. To understand how secure these attributes are, we must look at role-based access control. Here is the most critical takeaway. By default, the global administrator and other high-level administrator roles do not have permissions to read, define, or assign custom security attributes. This deliberate separation of duties prevents overprivileged accounts from accessing highly sensitive data. To manage these, you must explicitly assign specific roles. The Attribute Definition Administrator manages all aspects of the attribute sets and definitions. The Attribute Assignment Administrator is the role that actually assigns the values to users and applications. Furthermore, you have flexibility in scope. You can assign these roles at the entire tenant scope, or, following the principle of least privilege, delegate management by assigning them only at a specific attribute set scope. This ensures that an HR admin only manages HR attributes and an IT admin only manages IT attributes. Let's walk through this crucial RBAC architecture. At the top left, notice the Global Administrator node. The line connecting it to custom security attributes has a distinct X, highlighting that default access is strictly denied. Instead, control flows from two dedicated roles: the attribute definition admin, who defines the schema, and the attribute assignment admin, who assigns the actual values to objects. Below these roles, we see the scoping mechanisms. The dashed lines show that these roles can be applied either at the broad tenant scope for organization-wide control, or at the targeted attribute set scope for delegated, departmental control. This diagram perfectly maps out the principle of least privilege enforced by Microsoft Entra ID. How are these attributes structured under the hood? It all begins with attribute sets. An attribute set is simply a collection of related custom security attributes, and every single custom security attribute you create must be part of an attribute set. Think of it as a folder for organization and delegation. When you define an individual attribute, you must specify its data type. The supported types are Boolean, integer, and string. You also define its behavior. Do you want to allow multiple values to be assigned, or restrict it to a single value? Finally, you can enforce strict data governance by configuring the attribute to only allow predefined values like a drop-down list of approved department names, or you can allow free-form text entry. This structural flexibility allows you to map your organization's exact data requirements into Entra ID. This class diagram breaks down the data hierarchy. At the highest level, we have the tenant class, which contains many attribute sets. Moving down to the attribute set class, we see it acts as a container, defined by a name and description. Below that is the custom security attribute class itself. This is where the granular configurations live: the name, the data type, string, integer, or Boolean, flags for whether it is multivalued, whether it enforces predefined values only, and its active status. The solid composition lines connecting them show that an attribute cannot exist without an attribute set, and an attribute set cannot exist outside the tenant. It is a strict, logical hierarchy. Managing the lifecycle of these attributes requires careful planning due to some strict architectural rules. First, be aware of the limits. You can have up to 500 active custom security attribute definitions per tenant. When you are creating attribute sets and attribute definitions, name them carefully. Once you specify a name for an attribute set or an attribute, it is immutable. You cannot rename it. Furthermore, there is a strict deletion rule. You cannot delete custom security attribute definitions at all. You can only deactivate them. When you deactivate an attribute, it can no longer be applied to any new Microsoft Entra objects. However, be aware that any existing assignments on users or apps are not automatically removed when you deactivate the definition. This ensures historical audit trails remain intact, but it means you must manage your schema with foresight. Let's trace the lifecycle of an attribute using this state diagram. It begins with the definition created state, initiated by the attribute definition admin. It immediately moves into the active state. While active, as the note indicates, it can be assigned to users and applications. From active, an admin can move it to the deactivated state if it is no longer needed. Notice the bidirectional arrow. A deactivated attribute can be reactivated if necessary. However, look at the final transition from deactivated to the end state. There is a hard stop. It cannot be deleted. The note reminds us that while deactivated attributes cannot be assigned anew, their existing values on user objects remain indefinitely. Once our schema is defined, it is time for the attribute assignment administrator to put it to work. You can assign these attributes using the Microsoft Entra Admin Center, PowerShell, or the Microsoft Graph API. In the admin portal, the experience is straightforward. Locate your target user or enterprise application, navigate to the Custom Security Attributes blade, and click Add Assignment, From there, you select the set, the attribute, and input your value. Note that once an attribute is assigned to an object, you can update its value, but you cannot change which attribute set or name it maps to. Once populated, these attributes become incredibly powerful for administration. You can use the filtering tools in the Entra ID portal to query your entire directory. For example, you can instantly filter thousands of applications to find only those where a specific custom security attribute equals a certain compliance tag. This sequence diagram walks us through the exact flow of assigning an attribute. Our actor, the attribute assignment admin, navigates to the user or app profile in the Entra ID portal. The portal displays the available blades. The admin selects the custom security attributes blade and clicks Add Assignment. The critical step happens next. The admin chooses the specific set, the attribute, and inputs the value. The Entra portal then executes the right operation directly to the object, the user or enterprise app. The object confirms the assignment, and the portal refreshes to display the updated assignment list back to the admin. It's a clean, secure, and fully audited transaction. Let's bring this all together with a highly impactful real-world use case, scaling zero-trust architecture using conditional access. Imagine you have thousands of enterprise apps, and you need to enforce strict MFA only on highly sensitive ones. Managing this app by app is impossible. Instead, we use custom security attributes. First, we create a string attribute named policy requirement with predefined values like require MFA and block guest users. Next, your attribute assignment admin tags your high-risk applications with the value require MFA. Finally, you build a single conditional access policy. Instead of selecting individual apps, you configure the target resources to use a filter. Apply this policy to any app where policy requirement contains require MFA. Now, your security policy applies dynamically. Note, conditional access filters for applications only work with custom security attributes of type string. This is dynamic, attribute-driven security at its finest. This flowchart visualizes our real-world conditional access use case. We start at the top by defining our attribute policy requirement. We then assign the value require MFA to our high-risk apps. The magic happens in the next node, creating the conditional access policy. The policy hits a decision diamond where it filters target resources. If an app matches the filter, meaning its attribute contains require MFA, the flow routes to enforce the MFA access control before granting secure app access. If there is no match, the user proceeds through the standard access flow. This proves how custom security attributes transform static policies into highly scalable, dynamic security enforcement mechanisms. In our final slide, we cover visibility and automation. Because these attributes hold sensitive data, their auditing is isolated. All changes are captured in dedicated custom security audit logs, which require specific roles like attribute log reader or administrator to view. In fact, Microsoft strongly recommends keeping these diagnostic settings separate from your standard directory logs so that highly sensitive attribute values aren't inadvertently exposed to general security readers. Furthermore, we can automate the lifecycle of this data. Using Microsoft Entra inbound provisioning, you can automatically sync sensitive HR attributes directly into custom security attributes. Whether you are using Workday, SAP SuccessFactors, or a custom API-driven provisioning endpoint, you can map an HR field like pay grade directly to a custom security attribute in Entra ID. This ensures your identity security perimeter is always perfectly synchronized with your system of record. This final diagram connects automated provisioning with secure auditing. On the left, in the automated provisioning subgraph, we see our cloud HR systems like Workday or SAP pushing data via an inbound API into the Microsoft Entra provisioning service. The service maps this sensitive data directly into our Entra ID custom security attributes database. Following the flow to the right into the secure auditing subgraph, every one of these updates triggers an event in the custom security audit logs. Finally, as shown by the last node, accessing these logs or routing them to Azure Monitor via diagnostic settings strictly requires the specialized log admin role, ensuring end-to-end data confidentiality.